Yeah, so I'll start recording now. Once again, welcome to class. And in this class today, we are going to be looking into functions and formulas in Excel. Functions and formulas in Excel. So, like I was saying before, always check Mdth YouTube channel for you to be acquainted with the previous video of class. So please always check YouTube channel for all the videos of the classes you've been taking so far in this particular course we are dealing with, which is data analysis with Microsoft Excel, right? So always check Mdth channel for it. Put the notification button on so that when it is posted, you can actually understand what is happening, right? When it is posted, you can see all the details of the classes and the videos that we have in place. And I'd like to ask us this question. How many of us have seen and read the documents or the readings following this particular course? Remember, we told us that it's important for us to go through the readings. The readings are important because it is where we see all the theoretical backups of our practical sessions. Remember that all these backups that we have help us to understand what happened in our classes. So if you don't read those readings, I call them readings because it is brief. It is not so numerous. It is brief. So it's important for you to always do those readings so that you can understand what is happening in the practical sessions as well. Fine. So having given these announcements, let us continue with the order of the day. Yesterday, we were able to enter these two data in our worksheet, and we were able to format them properly using the right data format for each of the categories of data. And we have also seen how we can properly organize the data to look very clean and neat for analysis. This data, there is no duplicates in any of them. And what do you mean by duplicates? There is no occurrence of a single row twice. For instance, in the part that we have John Doe sells 44270, $65,000 and 101 as employee ID. If we have another row that bears 101 John Doe sells 44270, 65,000, that is duplicate. So duplicates occur row-wise in Microsoft Excel. Duplicates also occur row-wise in every other data analytics package you might find yourself to deal with. It might be Power BI, it might be SQL, it might be Python, R programming, or SPSS. There are duplicates in every data that you work with. Therefore, it's important for you to remove duplicates. But in this data set that we use here, this dominant data set, there are no duplicates. There are no duplicates. They are all unique data sets. Each row is unique. Each row is different from what the other row bears. Hence, we can go ahead to perform our statistical functions and formulas. The basic of them, we are going to see it come in play. And I've also told us to please always read our readings. They are important because all the things we are discussing in this particular call is in those documents you have. They are all in those documents you have. Please always find time to read those readings. You have access to them. You have access to them forever and ever. All right? So let's hop in. What is a function and what is a formula? We need to differentiate between a function and a formula for us to understand why we are using the word functions and formula. It's not wrong to call function, and it's not wrong to call formula, but how do you differentiate between the two? Well, a function is a predefined formula that performs calculations. A function is predefined formula that performs calculation by using specific values that are called arguments in a particular order or structure. But a formula is an expression that operates on values in a range of cells. That is two definitions given to functions and formula from my end. Other texts can bear this different function definition, but this is the best I can give you from my well of knowledge. That a function is a predefined formula that perform calculations by using specific values called arguments in a particular order or structure. But the formula is an expression that operates on values in range of cells. Now, let us demonstrate what we are trying to say. If you come to your Excel worksheet, we are using sheet 1. Let's open a new worksheet now. Let's do sheet 2. And we want to insert a function. When you go to your formula style in Excel, you notice that we have different functions in this particular function library. All right. So a function, let us differentiate it now. This is a function, and let's have formula. Now, a function is what you call predefined formulas that is used to perform calculation. Now, what are those predefined formulas? Something like sum, right? Something like average, something like minimum, maximum, and maybe standard deviation. I'm trying to give a number of examples. Then possibly the variance, and possibly the sum if, the VLOOKUP, the XLOOKUP, what again, the average if, and so on and so forth. So all these are all functions. Remember that there is no arithmetic or any operator in it. They are all words, functions, sum function, average function, minimum function, maximum function, average if function, so on and so forth. But when we now have operators, that's why we say that a function is a predefined formula, but a formula is an expression that operates, right? The keyword for formula is operates. So the formula for sum, we know, is A plus B plus C, right? This is an example of what you call a formula. Another example of what you call a formula can be, say, A colon A. This is another example of a formula. There are operators in each of them. And what are the operators there? Let me use my draw kit to explain, show you what operators are. This plus sign is an operator. This semicolon sign is an operator. So these are all operators in our data cell. This is cell F5 and this is G5. Sorry, F4 and G4. So this plus and plus in this particular cell F4 and this semicolon, this colon, sorry, in cell G4 are operators. Operators also includes, and notwithstanding, the others such as the minus, which is the hyphen. It also includes the open parenthesis and close parenthesis. It also includes the asterisk, also includes the backslash, and these are the operators used in spreadsheets, right? So all of these are what? Operators. So you see, saying there's a problem with this formula because I'm trying to put so much functions, formulas into one. So let me make it just become simpler one. So the hyphen, sorry, the hyphen, the equal to, the open and close parentheses, the backslash, and the colon, as well as the plus. All these are what? Operators. Minus sign, equal to sign, open and close parentheses, even open and close block parentheses, and colon and plus and backslash. All these are what? Operators, which we use spreadsheets in order to perform calculations. So when there is these operators in any range of cell, it is called a formula. That is why we have A colon A colon A. Now A colon A means everything in column A. A plus B plus C means everything in A plus everything in B plus everything in C. All right. So that is what all this means. When there are operators in any letters you are typing into a cell, it becomes a formula. Now, for the average function, we use this demo. Let's say this demo, A plus B divided by C, right? That's for average. I say that average is the mean of population or sample. Then for minimum is the least of them. And for minimum to be achieved, we also use, similar to the previous formula I've written, something like this, because it calculates the minimum in a particular cell. So on and so forth for other functions that we have. So what I'm trying to say is this, that a formula can exist on its own. It can stand alone. It's like an independent variable. But a function cannot exist on its own unless it has a formula. That is why the definition I gave us says the functions are predefined formulas that performs calculation by using specific values called arguments in a particular order or structure. Now, it means that while we apply those formulas written into the functions, it must have a particular order. That is why there are different functions and formulas in every spreadsheet package for analysis. The same thing goes with formula. Formula is not complete if there are no operators. So a formula is an expression that operates on values in a range of cells. And a cell will enable you to perform calculations using those formulas. Therefore, if there are no functions, if there are no formula, there cannot be any function. And if there is no function, we cannot perform calculations. So you see how the two of them are related to each other. Let's go back to the formulas library. In the formulas tab, you will see the library function or the function library as the case may be. If it was Python, you will see a notebook or a library of functions too. If it was Power BI, we also see a library of functions to all the DAX. So all these statistical data analytics packages have different function libraries that is used to write calculations and solve problems. Hence, we have, as you can see here, about 9 existing buttons to explore while we are dealing with functions. Are you working with a financial data set and you need to run some financial calculations? The formulas tab under the function library has a bunch of formulas for financial industries, like we say and we saw in the previous class we introduced us to Excel. These are all the formulas we use. These are all the functions we use for every financial industry or institute. Same thing goes logical, tests, date and time, lookup and reference, math and trick, and functions. More functions, statistical functions, engineering, cube, information, compatibility, etc., etc. So we saw this when we introduced us to Microsoft Excel for data analysis. Now, all these functions in place have their specific use. As you saw, you cannot use a function for mathematics and start operating it for lookup and reference. Although all of them are arithmetic in nature, but you cannot use a function from math and big for lookup and reference. That is why Excel has carefully arranged them in groups so that when you are looking for formulas for anything, you can easily find it in any of these buttons in this particular function library. And let's go back to our sheet 1, which bears the dummy data set we've used before now. And we said that we are going to perform statistical analysis on this particular dummy data set. But what is even statistical analysis? Well, statistical analysis is a scientific tool in data analysis that helps data analysts, data scientists, AI and ML engineers and scientists to collect and analyze large amounts of data in order to identify common patterns and trends and also convert them into meaningful information. All right, so sorry about the network glitch for a couple of minutes. We are having bad network glitch. Sorry about that. So we are back now. I was explaining or describing what statistical analysis is. And I said that it is a scientific tool used by data specialists, and it is used to help us collect and analyze large amounts of data to identify common patterns and trends and convert them into meaningful information. So this is like a long description I give. I want to shorten it now. And the shortened part of it is statistical analysis is a data analysis tool that helps us draw meaningful conclusions from raw and unstructured data. Let me go again. Statistical analysis is a data analysis tool that helps data analysts draw meaningful conclusions from raw and unstructured data. So that's been taken, right? Now, without statistical analysis, it will be hard for us to make conclusive decisions. And it's also be hard for us to identify or define the pattern that our data set follows. Statistical analysis involves working with numbers, and it is used by businesses and other institutions to make use of data in order to drive meaningful information. So without understanding statistical analysis, it will be hard for us to know how these data sets we have can actually be meaningful for this particular organization, or how this data set of ours can be meaningful for that organization. So it's important for us to understand analysis of statistics or statistical analysis, and that will help us to draw conclusions from raw and unstructured data. We cannot have statistical analysis with entire population. Hence, it's important to use just a sample of the data while running our analysis. We have 6 types of statistical analysis, and those types of analysis is equivalent, similar, or nearly the same with what we discussed in the 4 types of data analytics. The first of all statistical analysis is descriptive analysis. Descriptive analysis helps us to solve the problem of data using charts, graphs, and tables. So rather than drawing conclusions, it makes it easier for us to understand the data and also derive insights. Hence, the most used analysis of statistics in the entire industry of data is the descriptive analysis. Here, we collect data, interpret that data, analyze it, and then summarize that data in form of charts, graph, and tables in order to make the complex data easy to read. In this regard, I always bring in mind data storytelling. And without data storytelling, the stakeholder will not understand what is going on. The next type of statistics we use is inferential analysis. Inferential analysis focuses more on drawing meaningful conclusions based on the data that has been analyzed. It is being used to study the relationship between the different variables in the entire population. So, descriptive can focus on the entire population and give us some representation and summaries from that data. But inferential will now look into drawing conclusions relevant for the business objective or for the project objective, which then can help us to understand the relationship between the different variables in such data projects. Then after inferential analysis, we now have the predictive analysis. Here, the data analyst is tasked to analyze data in order to derive past trends and predict future events. The analysts always make use of historical data in this regard. And most of the persons that use predictive analysis are data scientists or those that are artificial intelligence scientists. They use this in order to understand what happened in the past and how it can affect the future. So the past can be predicted from the future, can be predicted from the past. And after predictive is prescriptive. In prescriptive analysis, the analyst prescribes the best course of action based on the results. This particular course of action will help the industry stakeholders to make informed decisions. Remember, like I said, these steps of analysis of statistics are similar, same, or equivalent to the previous ones we discussed in the 4 types of data analytics. But the other 2 we're going to see now is an entirely new thing when it comes to the 4 types of data analytics, and they are exploratory data analysis and causal analysis. Yes, an analyst even explores his or her data. But this exploratory data analysis is similar to inferential analysis. The only difference it has is that it analyzes the potential relationship between the data. That is why we talk about data modeling in Power BI, data modeling in Power Pivot, data modeling in R programming, etc., etc. So in Power BI and Power Pivot or other Power platforms, we see the potential relationship within every data table. Hence, exploratory data analysis helps analysts to know the actual difference that is involved in the unknown data associations. Here, while we analyze data using Power BI or using Power Pivot in Excel, we see how we can connect each table to suit into what we are looking for on the associations. Then the last of them is causal analysis. Causal analysis focuses on determining the cause and effects between different variables within the data set. So if you want to see why something happens and its effect on other variables, then that is causal analysis. For instance, maybe you're an analyst in the company XYZ, and the company XYZ producers of paint. So possibly you are producing enough paint in the company, but you notice that the sales made from the paint produced are not actually coming anywhere closer to the costs accrued in making the paints. That means something must have affected that to happen. Hence, when you try to determine why something like that is happening, and you notice that it might be because these paints are sold on a high price, so it's not everybody that's buying it. Or maybe the paints you are being produced is not actually reaching up to the standard of people who wants to buy it. That particular variable or experience have costs and effects on the revenue being generated from the production. This is causal analysis. Now, why are we discussing all this analysis, and we are always talking about statistical analysis? Well, statistical analysis helps us to eliminate unnecessary information and help us to catalog important data in an organized manner. It helps us to understand how the data plays a role in the insights we are trying to derive. It also helps us to design effective surveys and investigations, which will help to lead us in planning effectively in any subject matter of interest. There are numerous reasons why we are talking about statistical analysis. And as a business analyst or a future business analyst, we must understand how all this goes a long way in our analysis. Basically, there are 4 common statistical analyses that people use as analysts in the different industry. And the best of them are what we are going to describe in this particular topic of presentation. The first of them is the mean. A mean is a statistical analysis. Some persons call it average. Now, we are going to perform this statistical analysis as supposed to be on our Excel spreadsheet. So for the first dummy data, we have the 20 sets already set for us to work with it. Now, what do? We are going to create some statistical analysis on this particular data set. So let's type in statistical analysis. And we are going to start with the first of them, or which is the most wonderful of all data analysis used for statistical design. And the first one is the mean. Then the next is the standard deviation. Right? The mean, the standard deviation, and the next of the statistical analysis we are going to also derive here is the regression and the hypothesis testing. Right? So these are the major analyses that a lot of us who are data analysts always use in analyzing data, because they are always a go-to. Why is so? Is because most of the data project problem you encounter analysis will all fall down to you determining the mean, the standard deviation, the regression, and the hypothesis in your data sets. So if you're a statistical student, it's a plus for you, because the same thing you are talking about here is what you have already done while you are in your maybe second year or third year, or even you are used to it. So how do we get the mean of this particular data we have here? Now we have age, hours of study, and exam score. So we can try to take the mean of the age. So let's start with the age first. Mean of the age, mean of the hours of study represented with age studies. So I'm going to use age studies to represent that. And lastly, exam score. So notice that we are focusing our analysis basically on numerical data. That is the discrete data sets that we have in this particular analysis, because they are, of course, when it comes to standard deviation and mean, as well as hypothesis and regression. But in regression, we can actually add some of the qualitative data sets to it. So we are going to derive the mean of the age, the mean of the studies, hours of study, and the mean of the exam score. Let us see if there's any difference between all of these that we are talking about. For us to get the mean of the age, we are going to use 2 methods to achieve this, and the 2 methods will still boil down to the same results. The first method is to enter the function that will help us to achieve this inside this cell of choice. The second method is using the function library. Now let's start with the first method. We are going to enter the function for mean, and we say that mean is average. And what is average? Average is the results gotten after summing a list of numbers and dividing it by the number of items in that list. So it is the most simplest form of statistical analysis, which allows the user to determine the center point of a data set. So the mean is like a focal point. If you remember your physics, there's always a focal point in everything in physics. So that's what the mean is like. All right, is the central point of a data set. Also know the actual difference accrued from such list of data sets. Now let us get the mean, and we're going to enter the function of the mean, followed by the formula. To do that, you must use your formula bar. That is the work of this formula bar. The work of formula bar is to enter formulas into your cell, because the formulas you are going to enter are obviously going to pass that of the cell width. So it's a best practice for every data analyst to always enter the formula and the function of any calculation being made in a cell inside the formula bar. So we are going to enter the function in the formula bar, and we are going to click on it to activate it. Then the formula or the function for the mean is always the average. So every analysis tool uses average in place of mean, aside SPSS and some core statistical tools such as Lingo. So if you want to find mean, you can still use mean in Lingo and also use it in eView and also in SPSS. Same thing as R programming. But other packages call it average. So should in case you see average, it's the same thing as what mean. And another good practice is that before you start inserting any formula or any function in your formula bar, you must start with an equality sign. The equality sign must come first before you type in those formula in your formula bar. So you start by typing equality sign. And what type of equality sign? Excel understands that, oh, you want to do something, right? You want to do something. And you want that thing you want to do is called calculation. So equal to, now the function you're looking for is sum, the average, right? So average, when you enter the first letter, Excel has what is called semantics that helps you to see the other options you have. So by default, you are looking for average, but because you typed A, Excel is bringing out all the functions that starts with A. So you might scroll down or scroll up, you still see what you are looking for. So when you scroll down, you see that we have average over here, right? But someone like me who's already used to typing it myself, I can just type in average. And when I type in average, even before I finish it, Excel will give me a list of average functions. So I'm looking for the first one, which is average. And notice that there's a tooltip that follows it that says returns the average arithmetic of the mean. I don't know if you are seeing it. Let me share my entire screen so that you can see it clearly. So look at the word I'm talking about as the tooltip. I call it the tooltip. It says return the average arithmetic of each argument, which can be numbers or names, arrays or references that contains numbers. So it is giving you an idea of what you are looking for, which is the average, right? If you go to the next one using your arrow key now, it tells you what it does. The next one too, next one, just like that, right? So when you type in the average, the first word there that comes out is the function you are looking for. So just hit our tab on the keyboard, and Excel asks us which is the first number, which is the second number. So some persons who are new to data analysis might start typing 21, 22, which is 23. That is a very long protocol, and we don't do that in analysis. All right. For us to get what we want, to use what is called cell referencing. Cell referencing, and that means instead of entering the values ourselves, because that is how it's supposed to be from the function, we are going to reference the cell and use it as a easy goal for this particular task. So what I do here, I'm just going to click on the cell B2, which contains the age. right? That's the first age you're looking for. Remember, you said yesterday that this row header doesn't concern us for next analysis. So when I V2, I can easily drag down to select the entire column of choice. And when I do so, Excel has written the formula B2 colon B21. B2 colon B21. That shows that this is the choice of cells in this column, which you want to find the average. Or maybe you're someone like me that loves typing in as it is. I will just type B2 colon B21. When I do so, regardless of the casing I use, whether capital or small, when I get to this, I will close my parentheses. Now I'm done with writing the formula. What we have here is we are looking for the average of age. Average of age. And age is in column B2 to column B21. That's the range of age in this particular data set. So once I'm done, I will either hit enter in my keyboard or click on the good symbol here to enter it. So when I click on good symbol here, it enters it for me. Now look at what we have here. The average age is what? 22, which is the mean of the age. You can do the same thing for the hours of study and also for the exam score. But because we are data analysts and we love making things easy for ourselves, we are going to simply do what is called cell referencing. And that cell referencing is in regard of direct cell referencing. Now notice that age is in column B, which is the first column that we have already gotten the average or the mean. Next column is column C, followed by column D. And when we are entering the data for when we are entering the function for the mean age, we started with B2, which means that our cell of reference in all the columns of choice is going to be from row 2 to row 21. Row 2 to row 21. Hence, when I'm going to do for the mean of these other parameters of choice, what I'm going to do is to easily drag to the right. I'm not going to retype this formula again. I'm going to just drag this man to the right. When I do, what Excel does is that it will reference the relative columns after the first one I had. Now, if I click on this hours of study mean, I notice that it has referenced C2 to C21, which is the accurate column for hours of study. If I still go to exam score mean, it referenced D2 to D21. If I go to my data set, it is accurate. So what do we do here? What we did there is that we used the formula of interest and also made it easy for us to get other values by using a relative referencing. Now, since I already have C, B2 to B21 here, when I drag through, I'll have the relative values of each of the columns. Excel, what Excel did here was, okay, yeah, you've gotten for B, so the next column after B is what? C, D, E, F, G, H. So when you are dragging to the right in a particular function you've written down in a particular cell of choice, once you drag to the right, Excel will look it up as a relative referencing that tells it that, okay, this analyst has gotten first column. The next column after it is what he's looking for. Then it will now give you the desired response you want. Now, the next statistical analysis we are going to look into is the standard deviation. Now, what is standard deviation? I have a big long note for it, but I prefer to say that standard deviation is a stand or determine the dispersion of data points. How did that data point spread across the mean? The mean for age is 22. The mean for hours study is 12. The mean for exam score is 81. So how does this data set we have from column B2 to B21, C2 to C21, D2 to D21. How do they spread around the mean? Now, look at what we mean by spread around the mean. Let us get a particular sample that we can use for this. Let us get a particular, hold on please. Sorry about the network. So we have other data points. Let me share my screen again. Sorry about that. So this is the mean, like we are saying, right? And we have drawn it here. It turned out to be a star. Wonderful. So now let's draw other data points now. So these are data points. So this is data points now. So this I'm scribbling here are demo data points. Right? Demo data points. Fine. Now, the spread of these data points around this mean is what is called standard deviation. Right? The spread around this mean. So we have a wonderful mean here, and we have data points that all surround it. So the surrounding of the data points around this particular mean of choice is what we call standard deviation. And that's what we want to discuss on this next cell. The mean is 22. We want to find out how these particular data points from the first row to the last row, which is 20 rows of the data points, how much have they spread across the mean? Let us find out. So the second way you can also insert a particular formula into a cell of choice is by going to the formulas tab. We've seen how you can insert a formula by typing in that formula in the formula bar. The next way we can get a formula for ourselves when we want to run analysis is by using the formulas tab. And the formulas tab, you will see a lot of function library like we mentioned before. But you're not seeing statistical functions here. Hence, you click on more functions and then look at statistical here. You can then look out for your standard deviation by just scrolling down to S. When you get to S, you have two standard deviation here. We have standard deviation for the population and standard deviation for the sample. We are using standard deviation of sample because this 20 rows of data is a sample from an existing data, right? It's a sample from an existing data. Hence, it is a standard deviation for sample we are going to use, not for population. Population is the entire data set of focus, and we are using just dummy 20 rows of data. Now, if you don't want to go through this formulas tab and check the formulas library, you can just click on this FX on your formulas bar. Now, click on the FX, the insert function box will be open for you. And you now select a category of choice. So over here that says search for your function, you can come over here and type a brief about the function. So let's say we are looking for standard deviation. You can type about standard deviation. And here you go. And you type about that, it starts giving you options of standard deviation. Are you seeing it now? Different options are here. So when you scroll down, you see we have standard deviation of population, which is this guy, and standard deviation of sample, which is this guy, right? And other standard deviations of choice, even z-test and the rest of them, which is in relation to what we just typed here. Or possibly maybe you don't know the function you want to use, but you know that it's a statistical function. What do? You come to this box that says, or select a category. Then obviously that will be recommended for you here. So all you do is to click on the drop-down arrow and then choose statistical. When you choose statistical, you can then scroll to get what you are looking for. So these are the other two ways you can use to find a particular function of choice while analyzing your data with statistical analysis. So hence, we can choose our standard deviation from here. Let's go ahead and choose standard deviation from here. So let me just scroll down to S, because they are all arranged in alphabetical order. So let me scroll down to S. So standard deviation of what? Sample. Look at what it says here. Estimate standard deviation based on a sample, right? So you click OK. And obviously, this will come out for us as number 1, number 2, etc., etc. So number 1 here, which is just what we saw when we are typing in the average function, we are going to quickly select the cell referencing, which is this cell C2, sorry, B2, because about age, right? B2, we set it down to B21. And notice that the formula has already given you a result even before you click OK. Over here is the result, 1.386969434. That's the standard deviation. And even over here too, you can see it here as well. Formula results equals 1.386969434. So click OK, and you have the value. Now, this is the measure of dispersion around the mean, meaning that if you are to run this in a scatter plot, that is the age, it is going to be clustered, just like the sample that we used here, right? These are the data points, and this is the mean. So if you are to do the same to what value we have here, this means that this diagram I scribbled here is the same or equivalent to what values we have here, showing that the data points are not widely dispersed around the mean, but they are closely dispersed around the mean. As usual, we drag the bottom of the box and then head over to exam score. So with this now, we have gotten the dispersion of the data points around the mean. So I might decide to reduce the first 2 to 3 decimal places, because in statistics, we always are very much conscious of 3 decimal places. I don't know why, but that's how the rule of thumb is. So I'm going to make this to be in 3 decimal places. We are highlighting the 2 cells, come to the home tab, and reduce it by the number control over here. So we reduce the decimal place to 3. And then we come to this as well, reduce it to 3. So this is a perfect fit for standard deviation in our data sets. The next is regression, and the next is hypothesis testing. So we are going to do that tomorrow, regression and hypothesis testing. But let's do the same thing we did for this particular dummy data here for the next dummy data. And we're going to focus on the salary. So we're going to look at for the average, the mean of salary, and the standard deviation of the salary. All right. So we are going to copy this particular point and paste it here. Then we are going to look up for the mean, standard deviation, and just the mean and the standard deviation, because there's no how to run regression for this particular second dummy data, which is here. All right. So let's just focus on the mean and the standard deviation. So the mean of salary and deviation of salary, that's what I'm focusing on. So because we cannot run regression hypothesis for this, remember, we can't run it for this particular data because it is obviously the only data set that is a quantitative one in this analysis. So let's convert this hiring date, let's convert it back to the dates data type. So it should be a short date. Fine. So let's get the mean of the salary and the standard deviation of the salary. Click on this, and you're going to, I love using the formula by a lot. So we're going to type in the average function, right? Equal to average of the salary, which is here, and then close parentheses and hit enter. So average salary that was paid for this particular employee record is $73,700. How about standard deviation? The same thing too. We go to formulas bar, we hit the equal to, then type in ST. When type in STD, it brings out all the standard deviation formulas and we choose for the sample, which is stdev.s. stdev.x. And when we choose this, we now choose column O to column O21, close parentheses, and hit enter. Now notice that when you're entering all these functions and formulas in the cells, two things are common. Sorry, three things are common. And the first thing that is common there is that it must start with an equality sign. And when you have an equality sign, you enter the function name. Then start entering the formula. The formula starts with open parentheses, followed with the cell you are referencing, and an operator, colon, and then the next cell you are referencing, and concludes with a close parenthesis. This must be in your analysis. This must be in anything you are trying to enter as a calculation, whether be it a statistical function or a usual Excel function. This must be there. Why is that so? That is because it is the proper way to write a function and a formula. But we say that a function is a predefined formula which follows a particular structure or order. But the formula is an operator that operates on cells. So without these operators, such as the equality sign, the open parentheses, and the colon, we cannot do any calculation in these data sets. But because they are there, we can do the calculations. Hence, the operators or the formulas can work alone, right? The formulas can work alone, but the functions cannot work without the formulas. Like we say, functions depend on formulas to actually perform well, while formulas can stand alone. I can do a simple arithmetic here without entering any function name. For instance, I might say I want to get the average of the last two salaries paid. I can just come to my formula bar in any given cell of choice, put the first operator, equality sign. Then I will reference the cell of choice. I will say cell 20, right? Cell 020 plus cell 021. I will get the sum. Are you seeing it now? So without even putting the function name sum, I have gotten the sum of the two cells. I can say, okay, when I get this, divide it by 2 to get the average. I close open parentheses from the beginning, close at the hand, and then put the / and then divide it by 2. Hit enter. It gives me the average. So you see, without even putting the function name average, you've gotten the average of these two last salary. And without also putting the function name sum, we've also gotten the sum of the two last salaries paid in the employee data. Hence, like I said initially, functions are predefined formulas that must be done in a structured way or manner to get a result. But formulas are already existing operators that performs calculation in any cell of choice. And so far, we've seen how we can use the two first and most popularly used statistical functions, the mean and standard deviation, to get the actual values that we have as a result in these cells. In the next class tomorrow, we are going to see how we can perform regression analysis and hypothesis testing in these two data sets as well, so that we will flow easily with this and so on and so forth. Please, if you have any questions, you are free to ask. Any question, please, you are free to ask questions from what we discussed about statistical analysis.
Good evening, sir.
Good evening.
There's no question. Everything was understood.
Okay, thank you very much. So network is still playing with
Yeah,
okay.
yeah, yeah. I feel like rainy season is back. August break is over.
I'm telling you. But it's fine. We will tackle it. It's quite a challenge, but we will not say because network is bad and we won't do anything. So that's why the video is there for everyone to see. So that at the end of the
Yes, sir.
day, we'll be happy that we did. Yes. So thank you very much for all joining the call and your network being seamless so far. We really appreciate it. See you tomorrow and have a good
Okay,
night.
sir. Okay, sir. Bye bye, sir.